Hello, good afternoon, my dear students. This is Virat Kumar, lecturer in Electrical and Electronics Engineering from GPT Vaddepalli. With the semester of 4, the subject of AC machines. In the continuation from three-phase transformers, we'll be going to see auto transformers. The subtopic for today is auto transformer. In the previous class, we have learnt about three-phase transformers, types of three-phase transformers, advantages of three-phase transformers, conditions for parallel operation. These are the things which we previous class. And the today's objectives are, on completion of this period, you would be able to know the types of special transformers, auto transformer, saving of copper in auto transformer, and advantages and disadvantages of auto transformer, and finally the applications of auto transformer. So these are the things which we'll be going to see in this session. The things are type of special transformer, auto transformer, saving of copper in auto transformer, and advantages and disadvantages of auto transformer and applications of auto transformer. Now we'll move on to the types of special transformers. First one is auto transformer, instrument transformers, welding transformers, Scott connection, three-phase to six-phase conversion, that is double star, double delta, and diametrical connections. So these are some types of special transformers. One is auto transformer, the other is instrument transformers, welding transformer used for welding, Scott connection is special type of connection VV, and a three-phase to six-phase conversion, that is by double star or double delta or diametrical connections. Instrument transformers are like CTs and PTs, with current transformer and potential transformer, which are used to measure the values of huge values of current and voltage in the transformers that you may be learning in the EMI, electrical measuring instruments. Now we'll be seeing about auto transformer. An auto transformer is an electrical transformer with only one winding in it. The winding has at least 3 electrical connections. The winding has at least 3 electrical connection points called taps. And the voltage source is applied to 2 taps and the load is connected to 2 taps, one of which is usually a common connection that is also connected to the source. And a portion of the same winding effectively acts as part of both the primary and secondary winding. So an auto transformer is an electrical transformer with only one winding. The winding has at least 3 electrical connection points called taps. The voltage source is applied to 2 taps and the load is connected to 2 taps, one of which is usually a common connection that is also connected to the source, and the other is a portion of the same winding effectively acts as part of both the primary and secondary winding. Here is the auto transformer connection diagram. You can see here there is only one winding in it. So for this winding only you have primary and secondary, but whereas the secondary is connected through tappings, there are multiple number of taps which can be reduced and increased continuously through tappings. So through tappings it is connected to the secondary side, to the load. And also you can see this picture over here. This is a single winding, and here you have primary and secondary with tappings. EP is EMF in primary and ES is EMF in secondary. This arrow mark is a movable tap. It can be varied. Then auto transformer pictures. You can see the physical pictures of the auto transformer. Whereas this diagram is a variable and this is a fixed one. Variable where it has tappings, you can see this knob over here, and this is a pointer indicates. You can vary from 0 to maximum to minimum with some tappings inside in it. And this is a fixed one. You can obtain only one kind of output to the whole, one kind of output. Either it may be, so you can see clearly over here, either it may be 115 volts or 220 volts. You can take any one, depends on your requirement. There are only two outputs. You can take either 115 or 220 volts. Proof of saving copper. From the same voltage ratio and VI rating, it requires less weight of copper when compared to ordinary transformer. Since ordinary transformer has two windings and an auto transformer has only one winding, so from the construction we can clearly prove that it is saving copper. The weight of the copper in a winding is directly proportional to volume of copper and length of conductor into cross section and number of turns into current. Just please make a note of this. From the same voltage ratio and VI rating, it requires less weight of copper when compared to ordinary transformer. So weight of the copper in a winding is directly proportional to volume of copper and length of the conductor into cross section, number of turns into current. Okay, fine. Moving on to the next slide. Ordinary two winding transformer and the weight of copper on primary is directly proportional to number of turns into current carried, that is N1 into I1. Weight of copper on secondary is exactly proportional to N2 into I2. This is for ordinary transformer, ordinary two winding transformer. This is for ordinary two winding transformer. So for weight of copper on primary is N1I1, on secondary is N2I2. Now total weight of copper is directly proportional to N1I1 plus N2I2. As we all know, total weight of the copper both on primary and secondary is N1I1 plus L2I2. And in an auto transformer, weight of copper in section AC is directly proportional to N1 minus N2 into I. And weight of the copper in section BC is directly proportional to N2 into I2 minus I1. Then we can write, you can see them in this way, see, from A to C and B to C. From A to C, you can see that this is N1 and this is N2. So N1 minus N2 into I, and B to C is entirely N2 is equal to I2 minus I1. Make the diagram and the equations. Okay, next slide. Here, weight of copper in auto transformer is WA, and weight of copper in ordinary transformer is denoted by WO, ordinary. This is WO is ordinary transformer weight of copper, WA is weight of copper in auto transformer. That gives us where WA is equals to, we can see we have added both the things, that is N1 minus N2 into I1 plus N2 into I2 minus I1 by N1 I1 plus N2 I2. Now we'll just simply solve this. We'll be getting 1 minus K. We try to solve this, taking LCM and all those things, we'll be getting the value 1 minus K. So here we can understand that, so this in turns is equals to 1 minus K, then WA is equals to 1 minus K into W naught. So you can see here, weight of copper in auto transformer WA is equals to 1 minus K into WO, nothing but weight of the copper in ordinary transformer. That means if we know the weight of ordinary transformer copper, if we know the weight of the copper of the ordinary transformer, we can simply multiply it with 1 minus K, where K is transformation ratio, then we can find the weight of the copper in the auto transformer. So the saving of the copper is equals to from the ordinary to auto, so that is W naught minus WA. So if you just substitute the value of WA over here, you'll be getting K into W naught. How is that? You can just see it over here. See, W naught minus WA, that is equals to W naught minus WA is 1 minus K W naught. When you just take a W naught value common over here, you can get 1 minus of, we'll just open the bracket, minus into, plus is minus, into minus is plus K. So 1 minus and 1 minus is 0, then there is only a K into W naught. that just came over here. Okay, where K is the transformation ratio, as we all know that. The hence saving will increase as K approaches to unity. He's saying us that hence saving will increase as K approaches to unity. That means 1. Okay. We'll see some advantages of the auto transformer. Continuously varying voltage can be obtained, requires less copper, less in weight and smaller in size, cheaper, improves, and regulation will be better. So these are some main advantages of the auto transformer. We can see continuously varying voltage can be obtained, requires less copper, lighter in weight and smaller in size, and cheaper in cost. It improves the power factor from poor to good, and the regulation will be better. Just make a note of that. Now moving on to the next slide, there's some disadvantages. It can be used where K differs little from unity. It can be used differs only for the little value from unity. It does not provide electrical isolation between the HV and LV side. Since it has only one winding, so it doesn't require any electrical isolation between the HV and LV sides. And a failure of the insulation on the windings of an auto transformer can result in full input voltage applied to the load. So there may be a chance of failure of insulation on the windings of an auto transformer that can result in full input voltage applied to the load. That means there is no variation of the voltage. The auto transformers have the limitation of not suppressing harmonic currents and as acting as another source of currents. That means there are some limitations of not suppressing the harmonic currents. Actually, it has to suppress the harmonic currents, but whereas an auto transformer has some limitations on not suppressing the harmonic currents and as acting as another source of currents. So that harmonic currents are not suppressed, and so it is acting as another source of currents. Just make a note of them. Then moving on to the next slide, you see some applications of auto transformer to interconnecting systems operating at different voltages, as a booster in electrical distribution network, starter for starting of an induction motor, as variac, and used in laboratories and used as furnace, to interconnect systems operating at different voltages. So if there are any two kinds of systems operating on different voltages, then you can just interconnect them and maintain the voltage equally. And it can be also used as a booster in electrical distribution network. If there is any some low in the voltage in the system, then you can just connect an auto transformer and you can boost up the voltage by varying it. It can also be used as a starter for starting of an induction motor. So by maintaining the minimum value of the auto transformer and then connecting to the induction motor, by this the huge currents during starting to the induction motor is reduced and protects the motor from damage. And so the auto transformer are used as a starter for starting of an induction motors. And as a variac is nothing but a variable voltage device and used as a variac. It is also used in laboratories for different voltages and different scientific purpose. It is used as furnace transformer. Furnace where a heating chamber, by reducing the voltage you can produce huge amounts of currents and can be used as a furnace transformer. So these are applications of auto transformer. And you can see a summary of this session. We have discussed about auto transformer, how to save the copper and what of copper, and the advantages, disadvantages, and finally the applications. So these are the things which we have discussed in this session. So are you ready for a small quiz? Just a basic quiz. Copper required for auto transformer is less than 2 winding transformer, more than 2 winding transformer, equal to, none of them. It's very simple. It's less than 2 winding transformer, isn't it? It's less than 2 winding transformer. That is of about 1 minus K into W. O, WA is equals to 1 minus K into WO. The other question, number of windings in auto transformer is, it's also very simple, 1, 2, 3, none of the above. It has only one winding. Are you following or not? Okay. So there are some frequently asked questions from this session. There are given 4 advantages of auto transformer. Compare copper saving between auto transformer and ordinary transformer. Write any 4 applications of auto transformer. So I hope you have understood all the points in this regarding the auto transformer. So thank you one and all.